This is lesson 2.8 on two variable inequalities. Definition of a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. So it basically means, if you look at this picture down here, it means you're going to graph the line and then you're going to be shading on one side or the other. So we're talking about inequalities in the coordinate plane and rather than on a number line. And you may remember that the boundary line, whether it's solid or dashed, is determined by the kind of inequality that it is. We'll talk about that in a moment. Okay, so for the first problem, it says that you're graphing the inequality 6x minus 2y is less than or equal to 12. So subtracting 6x from both sides, and then dividing by -2. Remember that when you divide or multiply an inequality by a negative number, the symbol flips. So right here, that turned into a greater than or equal to. So now we have the inequality y is greater than or equal to 3x minus 6. So usually when we're going to graph the boundary line, it's going to work well to solve for y and put it into the y equals mx plus b form. Now these are inequalities, but the boundaries are lines. So the first thing we're going to do is figure out what the line should look like. If the boundary line has a greater than or equal to or a less than or equal to, so if it's greater than or equal to or less than or equal to, it's got the equal to part. That's not what I meant to do. If it's got the equal to part, then that's going to make the boundary line solid. If the inequality has a less than or greater than without the equal to, that's going to make the boundary line dashed or dotted. Okay, so for our inequality, because we have an equal to, our inequality is going to have a solid line. Okay, so again, here's our inequality. Y is greater than or equal to 3x minus 6. We know we're going to have a solid line. So you would start out by graphing, starting at -6. Notice on this graph we're going by twos, so that's -2, -4, -6. And then a slope of 3 would be up 3 over 1, up 3 over 1, up 3 over 1. Or down 3 and left 1. Now again, because it's equal to in the inequality, we would be filling in a solid line. Now in order to determine which way the shading is, we're going to test a point. So you can use any point that you want as long as it's not on the line itself. So if 0, 0 doesn't lie on the line, in this case it doesn't contain, the line does not contain the origin, then 0, 0 is a nice test point. So if possible, use 0, 0. So if this is our inequality, we're going to put, it's y is greater than or equal to 3x minus 6. If you put in 0 for y and 0 for x, what happens? Well, that turns into 0 is greater than or equal to -6, which is true. Since that's true, that means that we're going to shade in the direction of the origin. So since our test point was on this kind of like above the line there, and it was true, that means all the points on that side of the line would also satisfy the inequality. Okay, if your test point gives you an inequality that's false, then you shade the other direction. So if you cannot use the origin, then you just pick some point, like a point on the axis is always a good idea. So something like here, maybe 6, 0, or 0, -8. Okay, so pick a point that is maybe on one of the axes, or at least one of the variables is 0, and that makes it a nice calculation then to calculate. Okay, so sometimes instead of solving for y, if it's in standard form and the intercepts are nice values, sometimes we'll use intercepts instead. So we're really thinking about the line 2x plus 4y is, my 4 looks kind of weird, let me fix that. 2x plus 4y is less than 12. Okay, so first, before I even worry about actually what the graph looks like, I'm going to make myself a note that this is going to be a dashed line because it's not equal to. So when I go to graph the line, I want to have that visual cue there to remind myself that I'm not going to make it a solid line. Okay, so we're going to find intercepts, which means we're going to put in 0 for x and figure out the y value. If you put 0 in for x, that would cancel out this term right here, right? So if you cancel out that term, that would leave you with 4y is less than 12. Well, equal to 12, really. Oh, I didn't mean to make that. Sorry, I meant to make that equal to here. So when you put in 0 for x, that'll make y divided by 4 equal to 3. And then when you put in 0 for y, that would cancel out this term, and dividing by 2 would make x equal to 6. So 6, 0. Those are two separate points. It's not 6, 3. It's 0, 3 is the y-intercept, because it's on the y-axis, and 6, 0 is on the x-intercept. So when you put in 0 and solve for x, you're finding an x-intercept. 3, 4, 5, 6. When you put in 0 and solve for y, you're finding a y-intercept. 1, 2, 3. Okay, and so our line, since we're going 1, 2, 3, back 1, 2, 3, 4, 5, 6, I'm going to continue up 3, back 4, 5, 6, and get another point on there just to make sure our line looks accurate. And then again, remember that I said, well, I was going to make this a dotted line because it's a not equal to inequality. Now, since the origin is not on the graph, we're going to go ahead and test the point, and we're going to use 0, 0. So when you test 0, 0, what happens? Well, 0 going in for x and 0 going in for y, is that less than 12? Well, 0 plus 0 less than 12? That's true. Since it's true, we shade toward the direction of the test point. So that means that we're going to shade in the direction of 0, 0. So shade on this side of the graph. I kind of missed a little bit there. All right, now for the next problem, it's not really set up to do intercepts nicely, so this one we're going to go ahead and solve for y. So I'm going to subtract 5x on both sides. So I have negative 2x minus 2 is less than or equal to y. Now, we want the y to be on the left side just because that makes it easier to graph. And I'm also going to make a note here. This is going to be a solid boundary because of the equal to in the inequality symbol. So now if I rewrite this, this is saying that y is greater than or equal to negative 2x minus 2. Okay, so if I graph the boundary line, so we've got a y-intercept of negative 2, and we're doing a slope of down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. Okay, that's our boundary. And we want the line to go all the way through the coordinate plane here. Okay, we said that it was going to be a solid boundary line, so solid there. Now for our test point, if we have solved for y, then greater than or equal to will indicate shade up or above the line. On this problem, we didn't do that. And you know, sometimes if you have to like divide through by a negative, for example, you might have the inequality switch around. So if you're going to try to use this shortcut, you have to have solve for y and y on the left side of the inequality. So if it's greater than or equal to or greater than, that would mean shade above the line. Now, if you want to use a test point, that's fine. You can always use a test point. I'm going to go ahead and check it just to make sure that you understand what's happening. 0, 0 is not on this line either, but let's say it was. If I wanted to use a different test point, I might pick something like, let's say, 2, 0. Okay, so 2, 0 is the point that I'm testing. You could test 0, 0 again because it's not on the line. If it was on the line, you'd have to pick a different point. So let's say I put in 0 for y. I want to know, is that greater than or equal to negative 2 times 2 minus 2? Well, negative 2 times 2 is negative 4, minus 2 is negative 6. Is 0 greater than or equal to negative 6? Yes. So because it is, you shade in the direction of the test point, which is above the line, so that double checks what we just calculated. So again, if you're using intercepts to graph, you have to use a test point. You need to use a test point in this case. If you're solving for y and you have y greater than or equal to, or y less than or equal to, or greater than or less than, if you've solved for y, then you can use this kind of shortcut method. So I sort of have that indicated here. If you solve for y, and this would be true whether it's greater than or if it's greater than or equal to. Okay, these mean shade above or to the right. If it was a vertical line, you would shade to the right. Okay, y less than or less than or equal to means shade below or to the left. Again, a test point is necessary unless you have solved for y on the left side of the inequality. Okay, I'm going to kind of set up a couple of these next ones, and then I'm going to have you finish the rest of them yourself. So x is less than negative 4. Well, first of all, what does x equal to negative 4 look like as a line? Well, think about an xy chart. X is negative 4. There's no y, so y could be anything. X is negative 4. Y could be 2. X is negative 4. Y could be negative 5. Okay, when you plot those points, 1, 2, 3, negative 4, 0, negative 4, 2, negative 4, 1, 2, 3, 4, 5, what kind of line are you tracing out? X is always negative 4. Okay, you decide if this should be solid or dotted. And then which way should the shading be? So if it's saying you want x's that are less than -4, this is going to be a vertical line. If you want x's that are less than -4, which direction would that be? Would that be to the left of -4 or to the right of -4? So you graph that and figure out what the graphing should look like. Okay, a hint for the next one. This is not y is greater than 2. This is y is greater than 2x. You might want to think of it as 2x plus 0, because graphing 2x sometimes is confusing, but 2x plus 0 in slope-intercept form is a little easier. Again, always start with solid or dotted, solid or dashed, and then graph the line, and then figure out the shading. Okay, so I want you to finish these last 4 problems. On the third one here, I'm asking you to graph with intercepts. Don't solve for y, graph using intercepts. And this one, you'll have to use a test point because it's not been solved for y. This is the end of lesson 2.8. These last 4 problems need to be completed for these notes.